Hi everyone. Today, at the end of the assignment, you are going to make a drawing, and that drawing is going to have to do with an experiment called the electrolysis of copper chloride. And so I'm going to show you two things. One, here I'm going to explain that experiment a little bit. And secondly, I'm going to show you how to draw just to make sure that you can do that easily at the end of this assignment. So I am going into Drawing tab in my Google Doc and then going into New. And here's my drawing. And I'm just going to use Scribble to be in this. And so here is what I'm going to draw. Now, remember I said we were going to do the electrolysis of copper chloride, and that's going to give us some clues about what's happening when elements combine. So you are going to actually have a beaker, or in the video, you're going to have a beaker. And so I'm making the beaker actually pretty big here because you're going to have to draw on your beaker. All right, in that beaker is going to be some blue liquid. So I'm just drawing the surface of that liquid. There's your blue liquid. All right, and into that blue liquid, you are going to put some electrodes. Now, you know that an electrode is usually a metal piece with either a positive or a negative charge. All right, so the metal pieces, they're not going to be what you normally think of as a metal today. In fact, this won't be a metal at all. It's going to be a carbon electrode, but it will still have a positive on one side and negative on another side. It's going to be hooked up to a power source. You might think of it as being hooked up to a battery. You know that batteries have positive ends and negative ends. And so you might think of it as hooked up to a battery. It's the same thing, a positive and a negative end. Into your liquid, you're going to put the electrodes, or the person in the video is going to put some electrodes. All right, so there's one. You have to have a positive one and you have to have a negative one. So there's going to be two. They're made out of carbon. They're just black rods. And one of them is going to be positive and one of them is going to be negative. So I'm just labeling it positive and negative here. So this is the positive electrode and this is the negative electrode. It doesn't let you make sideways lines very easily. And so we got the electrodes now, and we know that we have copper chloride in this liquid. All right, well, you can tell from the name that it's made of copper and chlorine. But you're going to find out what happens there, and then you're going to make particle drawings of this. Okay, and so let's see, what else do you need to know for this drawing? The positive electrode is going to be in the drawing. It's going to be the one that is, or in the video, it's going to be the one that's hooked up to the red wire, and then this one's going to be hooked up to the black wire, just so you can tell them apart. Now, you need to be very, very careful when you make your drawings at the end that you have the positives in the right direction and your negatives on the right direction, and you need to explain carefully what is happening there. So you'll be able to do that. And I'm going to give you a lot of questions that are going to make you think through this problem so that you can draw. What you want to do is think of the answers to the questions as you go through this, because that's going to tell you what's happening in the drawing. One last thing, we are putting this into the liquid. All right, this is the formula for copper chloride that you're going to be using. Now, you guys have drawn particle drawings of things when they've dissolved before, okay? But this drawing that you're making today is going to, in your particle drawings, you're going to make particles that show what's happening in here. And there's going to be some evidence from the electrodes right here and right here as to what is actually happening when copper chloride dissolves in the liquid, all right? And that's what you're trying to get to. What really truly happens when copper chloride dissolves in the liquid, all right? So that is your object, and you're going to have evidence on the electrodes that's going to tell you what's happening.